Hello, and welcome to another episode of Hacking with Friends. My name is Kody Kinsey. I am a security researcher at Varonis. And it's not Michael today. This is a computer person. His name is Brandon. So Brandon has a job where he literally talks to computers. And today he's been happy enough to disconnect himself for just a little bit and talk to us today. Thank you, Brandon.
You're welcome.
Cool. So we're going to do something that's pretty interesting today. I think that a lot of people have accepted smart devices into their homes without really thinking about how they can be controlled or all the different things you can do with them. And I teach a lot about Wi-Fi hacking, but once we get to the point where we're in the network, I always say you can have all sorts of access, or you can directly interface with IoT devices. And today, that's pretty much exactly what we're going to be doing. So Brandon, do you know what this is right here?
That looks like a light bulb.
It is a light bulb. So this is a smart connected light bulb called a Yeelight. And this Yeelight is connected over Wi-Fi so that if you have a mobile application, you can just address it over Wi-Fi and make it do whatever you want. In this case, I've turned it on the lowest color of blue and red and just made it turn purple. Now, this is addressable over Wi-Fi in general. And this is a feature called LAN control, where you can basically go over the local network. And even if there's a problem connecting to the overall server that controls these lights, like some people want to be able to do this from anywhere, and we'll set it up so that this actually connects back to a kind of sketchy server in China or somewhere else. I noticed that it says that it's connecting to a server in Portland, but this server will actually manage the remote communication. So if you try to turn on or off the light while you were away, then this will go through a server in, I guess, Portland is what this particular product says, and then it'll come back and turn off the light, even if you're somewhere not on the local network. Now, alternatively, you can just disconnect this and have it running on your local network and control it when you're at home, which is a pretty convenient way of doing this if maybe you're having a hard time with a spotty internet connection, or you just don't want trying to have all your data. Now, that being said, there's a lot of things here that aren't authenticated. And because of that, we're able to do some things here that aren't completely really expected if you're just installing this light and thinking you're having sole control over it. You kind of get the impression when you set it up that, you create a password and whatever else, that means that the thing is locked down. But that's not really the case. In fact, if someone gets access to your Wi-Fi network, then they can start addressing this thing directly, and they don't need to use the app and do it the traditional way. We can actually start scripting this and even abusing or just creatively using some of the internal features to do things like even use Morse code, as Brandon here has figured out how to script while we were messing around with this earlier today. So Brandon, can you think of why it might be interesting to control an Internet of Things device like the smart light?
No.
Smuggling out a message, perhaps?
Right, so if you're in prison and you want to get a message
to your drug lord to tell them to carry out a hit.
Obviously, you need to control your smart light from your illegally smuggled in phone.
Right. Well, another thing is a lot of these lights have an ESP8266, which we've talked about before, which is a smart, or not smart, Wi-Fi connected microcontroller that's designed for IoT development. And you can actually flash these to be malicious if you get direct connection to them. So if you're on the same network as one of these, you can often flash them with updated firmware that actually is malicious and use it to then hunt down and disconnect other Wi-Fi networks, stimulate handshakes if you wanted to grab a Wi-Fi handshake and try to crack the password, and otherwise attempt to do a bunch of nefarious things. So there's plenty of botnets that in the past have been chained together from IoT devices. The Mirai botnet, have you ever heard of that?
Yeah.
Yeah. So what do you know about it?
Not much, but scary.
Yeah. So, I mean, what
took over a lot of devices.
Yeah, and then the combined power is really what was so crazy about it, because as soon as it took over all those devices, they're really, really like small things, but when you put together a whole army of them, you can take down major corporations. And that was the source of that huge outage in the United States, where they took down like DINS or whatever, the DNS provider. And if you don't have DNS, you can't resolve websites. So it's a really big threat that we rely on these centralized services that can be taken down with giant botnets that are things like this Internet of Things light bulb. So today we're going to be just doing some pranks, but really the threat here is that as soon as you're on a local network, you have complete control of that device, as much control as the owner might have. So short of actually physically going in and factory resetting it, which requires you to flip light switch on and off, you can do pretty much everything just by being connected to the network. that there are some ways of mitigating this risk. And we'll go into that today because while we were testing this, our production assistant, Michael, spoiled our fun and actually locked this down so that we weren't able to affect it because it was only controllable over the app. At which point we started DNS spoofing the lights so that they could no longer connect to the app, and the war escalated. So there's a lot of different things you can do to attack these lights and try to protect them. We'll go into a couple ways that we can mitigate these attacks today. But really what we want to show is how somebody just from a terminal can start interfacing with these Internet of Things devices. And we are not the owner. We didn't set this device up. Like, we are not the person who should have the access to it because we're not holding the application that's actually trying to control these through Home Assistant. Now, Michael set this up through Home Assistant so he could basically control all these smart lights with voice commands and tie in other sensors so that they could communicate in harmony. And our job as hackers has been messing them up as much as possible, creating a bunch of false positives, and otherwise creating ghosts in the machine that make him doubt his surveillance state he's trying to build in our house. So we're going to go today into a really cool library that makes it possible for us to directly address these lights. And these are Yeelights, which is a specific brand of smart light that's really popular. Now, Brandon, have you ever used one of these devices from the actual official app that they work with?
No, we were just hacking it, from the command line.
Yeah, so the app that they work with is really slick. You can integrate it into Google or Amazon or all these other products. So you can address it via a smart speaker, and it makes it really convenient to be able to set these lights on and off. But they do stay on all the time. And while they might have the actual LED off, they're still connected to the Wi-Fi network. So you can control them. And if you've watched Mr. Robot, there's a particular scene where this lady with a smart home gets woken up abruptly by a bunch of her lights going off, music playing super loud, and basically doesn't have any control over her stuff. As soon as she tries to turn off something, it immediately turns back on. And that's kind of what we're going to show off today, at least on my portion, rather than trying to sneak messages out, which I think is a more useful and elegant way of using this kind of access. We're instead going to create a jammer that basically makes it impossible to use one of these IoT devices by either locking it on or off and denying the person with legitimate access the ability to try to use it. So this is another way that we can use these devices if we want to basically take away the ability of someone to use the device they really need, like maybe a light at night if they're walking around their dark house because they heard a noise. There's all sorts of ways that this would be maybe useful to a hacker or someone who is interested in abusing this sort of access. I mean, if all of a sudden someone was able to cut the power to your house, but they didn't actually cut the power, they were just sending all of your lights the command to stay turned off so you couldn't turn them on. It's essentially the same thing. So these vulnerabilities are real. And if you set a weak Wi-Fi password, it means a hacker could come in and start affecting devices that they shouldn't have permission to access. And that includes things like IoT cameras and other sorts of IoT devices that exist in a home. Brandon, can you think of other IoT devices that could be abused?
Oh yeah, smart toaster.
Smart toaster.
Just start toasting all that toast.
Actually, I think that was one of the examples where they tried to make toast or something and it ended up overheating it. You could also melt all the stuff in the fridge and spoil all the food. You could mess with the climate controls and make it super hot.
Well, I mean, even with light bulbs, right? Like if there was some kind of bug in it that would make it overheat and you could trigger it remotely, like you just start a fire in someone's house.
Yes. So the extreme end of this is if you do something like the Stuxnet attack, where you're actually messing with the firmware to cause it to destroy itself, that's a potentially serious attack where, you could burn out one of these things and maybe create an electrical fire that could potentially burn someone's house down.
Right. I haven't seen that yet with these light bulbs, but
Yeah,
maybe.
I'm not saying that Yeelight will do this. We don't know that for sure. But another example might be, for example, Sonos speakers. So Sonos speakers can be addressed, and I love it when you go to a cafe and they just are convenient and nice enough to have a Sonos speaker on the public Wi-Fi network that they provide to patrons. And you can just turn on increasingly aggressive songs until they're just like, what is going on? There's that's a lot of swearing in the song. What's happening? So Sonos devices can easily be abused by just addressing them the same way we're going to be doing this. You can also do this with things like Apple TVs if you want to be able to just abruptly change them to a video that's super weird. If you're on the same network, you don't need to be authenticated, and you can address this from basically any device that's connected. So the attacks that we're showing off today might not be using the exact same library, but they basically would be using the same methods in order to interact with an Internet of Things device that's on the same network as us. And we're talking about how you could break into a network. This could just be a friend giving you the Wi-Fi password, or it could be going to a cafe where they give you the password as soon as you buy a cup of coffee, and they haven't taken any of the defenses we're going to go into today that would prevent this sort of attack. By the way, do you know any defenses against this?
Not off the top of my head.
Yeah, so 1 Health Robot is network segmentation.
Hmm.
If you can't communicate with other devices on the network, you can't mess with them as easily.
Sure.
Yeah. Okay, so let's go ahead and switch to my screen. And I have a very, very basic command here that I want to show off. It is a single line, and this is all that I need to basically call the library that I need to interact with this light bulb, and then send it a command to set its brightness to the lowest level and turn it purple the way that it is now. So this is a single line. It's very, very basic, but this is the seed of what we're going to be working with today. And I just wanted to show off how simply we can address this light. And of course, I can make this command even shorter if I want to. This would be one of the more basic commands to just set the brightness to really, really low. If I want to set the brightness to higher, I can run this, although I'm not sure if I'm in Python. Yep, there we go. So this is just a very simple way we can address the light in a command line structure. And we're going to go into what all this means, but you should just see that it's as simple as the single line of Python in order to get this to work. So not very intimidating. You don't need to be a big computer science person like Brandon in order to understand how to do this sort of thing. What do you do all day?
Just mess with lights.
Yeah. All right, so on my screen, I have this Yeelight library. All right, so the Yeelight library is developed in Python for the ability to interact with these lights, again, unauthenticated. So Brandon, what's the difference between an authenticated versus unauthenticated way of communication with a device like this?
You mean if it had like a password to control it? Or do you
Yeah.
mean over the network, whether it's using HTTP or HTTPS?
Exactly that, the second.
Well, if it was using HTTPS, you could have a more secure connection based on. So if like his phone is usually controlling it, that's a secure line.
Right.
So it would just be his phone that could control it.
Exactly, and we wouldn't be able to see the commands individually. And if we didn't know like the secret key that was set up between the device and his phone, then maybe we wouldn't be able to communicate with it at all. So there's ways of authenticating the communication between an application and the device where some random person on your Wi-Fi network can't control it directly, like maybe having a password on the device and then using HTTPS. So all these things are different ways that you can make this more secure and basically not fall victim to the kind of things that we're looking at today. But because these devices are designed for convenience and they want anybody who has permission to be on the local network to be able to address them, they're generally set up so that anybody who's connected can address them this way. So, okay, you can go and see this documentation at yeelight.readthedocs.io. I'm looking at the English version, so /en/latest. And here you can see just the basic installation instructions. So is this for Python or Python 3? I don't even know. Yeah, it's just Python, right? Or is it Python 3? Python 2?
This is Python 3 as far as I know.
Okay, it seems to run in Python, at least in both.
We've been using Python 3. Maybe it'll work in Python 2, but maybe not.
Well, maybe.
Wait, does it say at the top?
No, I thought it
Nope,
would.
nope.
Yeah, it usually does. But the pip install, usually it's like, isn't it pip 3 for Python 3?
So it depends which version you have installed. I think Python 2 is pretty out of date now.
Yeah.
So
Yeah, I just honestly don't know if it's like alias, and if you say pip, it assumes you mean pip 3. Now that's Python 2 is sunsetted.
Yeah, it depends on your setup. So if you want to make sure, then yeah, you can do pip 3. I think you're set up for Python 3, so you're fine.
Okay, cool. So as soon as we call Python, and I'll exit out of the Python instance I had here. Oh, no, wait, I'm done. Quit. Core.
All right.
Okay, so the first problem here is in order to address any of these light bulbs, we have to find them. So here, if I type Python 3, oh, no, I couldn't get this to work, and here's why. So when I try to import Yeelights,
Interesting.
Yeah, so I'm going to do...
So what if you do Python space tac version?
Yeah,
Okay,
see?
so you're on Python 2. Interesting. So
Yeah.
just try Python and see if you can just use it. Because I definitely was using Python 3. Oh, no, just run Python.
I'm just...
Okay.
Well, oh my god, well, that's not going to work. No, please, no. Yeelighty.
I'm going to install
Yeah,
it
see?
too because it's not installed on this computer.
See, it says it's already installed, but if I try to run Python 3, it doesn't see it. It's very
Interesting.
strange. So anyway,
Yeah, I have seen that before. I can't remember exactly why.
I've done too many things with this Python. So anyway, so I'm going to do Python. And now I'm in my Python instance, and I'll import Yeelight. Cool. So, okay. The first thing I really need to do is discover bulb. So here, I think I've already imported this, right? If I just do the general import, or do I need to import this specifically?
You need to import that.
Lame. All right, so we import discover bulbs, and the discover bulbs function is going to allow us to scan the network and basically identify every bulb that's there. So, let's see. In order to make this work, we can do the discover bulbs function, and I usually create a variable that's just scan equals discover bulbs, and then print scan. So this should scan the network, and okay, here we go. We have the light that we're going to be working with today, and we managed to discover it. And what format is this in? Is this JSON? No, or is it just key values?
So it's what Python printed out from what is probably JSON, or at least a Python object.
Yeah.
But yeah, I mean, you got these little U's in front of everywhere, and it's not double quotes, so it's not valid JSON.
Yeah. It looks like it came from like a JSON request or something. Yeah. So once we discover the bulbs, we can see that there's different like nested values, and the IP address is really what we want to capture when we're addressing them. So I went into my IDE and I created a little loop that allows me to discover all the bulbs. So I'm gonna just copy this. Oh, what?
But doesn't discover bulbs discover all the bulbs?
It does, but what I want to do here.
Oh, is just strip out the IPs.
Yeah.
Gotcha.
Okay, so here is the IP address, because if I want to address a particular, let's say I want to address a particular one of these. Now I have a list of all of them. So if I had like 20 lights, I could iteratively go through each one and then address each one and make them do something. So in this case, I found the one that I want, and I can just create, a variable that's just this. So my bulb equals just this. And then from now on, I can just, actually address it. Oh, wait, no. Yeah.
But have you imported bulb?
No, I haven't yet. So now I've just saved the IP address. So, all right, so the next step is to, as you mentioned, import the bulb. So from Yeelight, I'm going to import bulb, and then I'm going to define the bulb, which I can do. Here you can see I'm just using bulb equals bulb that. I can just do my bulb now. So this is a very bulbous statement. Nice.
Yeah, I've been calling things bulby, but I don't know.
I'm not sure about that. I haven't heard that used.
Bulbous, bulby. I mean, I don't know. They're all kind of gross.
All right, so capital B for bulb, and then my bulb. And then if we want to address it, we can do like bulb to turn on and bulb to turn off. It's already on, so we can turn it off. So let's run this command. So bulb equals bulb, my bulb.
Bulby.
You're welcome. See if it runs. Okay, cool. So now we can do bulb turn off. And it says, oh, okay. And did it turn off? I can't even see it. I think it did.
Yeah,
Okay. All right, cool. So it turned off. So now let's change this to turn on.
I like how it's asking if you're okay.
Yeah, you okay?
You okay
No, I'm
with
still
this?
here. It's fine. So then you can see there's other examples that we can just run if we want to do that. If we want to turn it to red, then we can just copy this and paste it. Boom. We can also set the brightness level. So if we really want to max this thing out, we can go to 50% brightness. We can go to 100% brightness, very bright. Or we can go down to 1% brightness, not very bright. So these are the basic ways that some random person on your network can actually start messing with your Internet of Things devices. It really is as simple as that. So if we want to start iteratively going through and jamming these things, then we can do so in a very simple way. And I like this attack because it basically means that whoever is trying to use these really can't do very much with it. So if I go back to my Python script, then let's take a look at what we're doing. There's a bunch of commented out stuff that I'm going to get rid of. This is just the one-liner I showed off. So here I also created a couple different ways of just turning everything always on and then turning everything always off. So these are just functions that are basically defined so I can very easily spam the same command over and over and over to just turn a light on or turn a light off. So if I want to take a look at the code underneath this, I can see scan equals discover bulbs. So this is the line in which I discover all the bulbs on the network. I'm also printing the scan just to make sure that everything's working properly. Then I say for scan and scan, for scans and scan. So for, I could probably rename this to be something more clear, but so basically for every result in the scan, print the IP address. So this is just me keeping track and making sure that we're sanitizing our input and we're not grabbing the wrong result or there isn't no result. So after that, then I'm going to, in this case, I'm not going to address our specific bulb, even though I know where it is. I'm going to assume I don't know where our bulb is. Mm-hmm. So I'm going to do the always off. And basically what this is, and I really don't need any of this at this point if I just wanted to create a jammer that turns it off. With this import and then this definition and then this pre-scan to discover every single bulb on the network, I can identify every single bulb and be able to shut it off. So let's run this and see if there's any errors. Yes, there is. Always off is not defined. Def always off, but I tried. Okay, let's see. Oh, wait, no, I'm dumb. I didn't. Always oof. Okay, and it turns off. So what's happening now is it's persistently sending the signal over and over and over until my code crashes. Because eventually there is a limit to how many times you can hit this. So what I found is that it's really easy to start jamming this, but after a certain period of time, when you send a certain number of requests, you lose the ability to send any more or it stops processing them. Brandon, have you seen this?
Right, yeah. So there's something called, what I always think of as magic mode, but it's music mode or something, right? It's music mode?
Yeah, like music mode.
So once you turn on music mode, it removes the limit. So instead of 60 requests, you can send as many as you want.
Right, so that is the limit. So 60 requests per minute, is it?
I think it's 60 a minute, yeah.
Yeah, so 60 is not a lot to work with. It basically means that you get to make one change per second. So if you're doing something tricky, like trying to use like Morse code to like flash a message to someone or something like that, then, you know, theoretically, like you're probably not going to be able to do that very quickly. And it's going to be very hard to discern what's like a dot and a dash because everything's going to be, you know, going very slow. But fortunately, there's this weird mode, which I think should be called like admin mode or like advanced mode or direct mode. But instead it's called music mode.
Music mode, I think, yeah.
Yeah. It's a little strange. We're not totally sure why it's called that, but it basically gives you much more direct access to this device. So for this to have this basically baked in feature that's pretty well documented that you can access to override some controls, you know, a hacker might initially get frustrated and be like, oh, I created this great jamming script, but it just doesn't work. Like if for some reason it's just not working properly. Well, there's also a way to actually get around that if you just read some of the documented features and learn how to abuse them to basically do something that there's a rudimentary way of protecting against built into the bulb. So this is like a kind of rate limiting that is probably designed to, you know, prevent these sorts of attacks from a malicious user who's just automatically just hitting the thing over and over and over. It just makes this harder to automate, and you can see my script crashed here after it ran a certain length of time. So really, if we want to be able to kind of go the next level, we just need to read the documentation on this a little bit and then design a script that's able to overcome that by switching it into a different mode. So Brandon, let's switch to your screen and we can talk a little bit about graduating from just doing this basic scripting and basic changing of lights and colors to doing something that's a little bit more fun.
Great. So I actually don't have it installed. So first we're going to do that.
Yeah, it's fine.
Okay. So this isn't my computer. We're going to have to, you're going to have to tell me the password in secret.
Let me see.
Oh, or you can type it, yeah.
Cool.
All right, let's get this going.
All right, so we're starting on an Ubuntu system. So we're going to do all of this from basically the point where you don't have anything installed. So if you're following along, you should actually be able to, provided your internet's not too slow, follow along with us. And if you happen to have a Yeelight on your network, then you should be able to address it using this script. So pretty cool. And like I said, while this doesn't work on every single light bulb, there's usually, if it's a popular enough light bulb, a documented way of interfacing with this. And when I was checking out some of the interesting tools that were available from Black Hat, I noticed there were a series of them that were focused on exploiting IoT devices by recognizing protocols like this. So because a lot of manufacturers reuse these protocols, it's really easy for us as hackers to just put together a bunch of protocols and start sniffing out and seeing which devices on the network might maybe support that protocol and allow us to communicate with that. Because again, a lot of these are unauthenticated. So if we discover a protocol that works and we're able to start sending commands, a lot of time we can just start messing with that IoT device and maybe blasting loud music or flashing a light.
Cool.
Yeah.
All right, so it should be done. We can test it out. We'll open a file called bulb.py.
Nice. All right.
All right.
And you're using Vim.
I am using Vim. What do you use? Oh, you're using, what is this?
Well, this is an IDE because that's how I use. Because that's how I code. But it's Python.
Okay.
Yeah. But I use Nano.
Okay.
Why did you laugh?
No reason.
Okay.
No reason.
All right. It just seems like a real like Vim person thing to do.
Okay. Well, I mean, Nano.
Oh, I forgot. Sorry. You might not have seen the sticker on Brandon's laptop. He's very serious about Vim.
This isn't my laptop, but yeah, I do have a sticker.
Yeah. Oh yeah. Sorry.
So first, I'm gonna just make sure it's actually installed. Okay. So first, let's just try to import. I always want to say Yeelight.
No, it's not a Yeelight.
I mean, it would be much more fun if it was a Yeelight.
More carefree.
Okay. All right. So let's see. Oh, great. No. Okay. Did I spell it right? Fantastic.
Yeah, you spelled it right.
All right. Well,
so you got to do a pip install.
I did. Oh no, I didn't. I just installed pip.
Yeah.
This is I'm starting from real square zero here. Square zero?
Square one.
Square one.
Yeah.
Yeah. I mean, if you're a programmer, it's square zero. Okay. All right. So let's do pip install, and then it's not Yeelight. Yeelight.
Yeelight.
Let's try it.
Collecting the Yeelights.
Oh, good. All right. Let's see if we got it. Import Yeelight.
Yeah, cool.
Woo.
All right.
All right.
So it's just that easy to get set up. Like a lot of these Internet of Things devices that do have Python modules associated with them that let you address them, it's really relatively that simple to get set up if you have Python installed on your system.
Yeah. Okay, so let's pull up the documentation. Great. Let's just get started here. Okay, so again, first thing we want to do is actually discover this Yeelight.
Yeah. Yes.
So I'm gonna try not to say it wrong for the rest of the time. All right, from.
You did
I
it again.
I already did it.
Yeah.
From Yeelight. Okay. And I can't spell the board either. What is it? Discover bulbs. Discover bulbs. Let's start discovering these things. And then we're also gonna need
For bulb.
Bulb. And I think those may be one other thing, but if not, we'll figure it out.
I think that's it. Okay. Well, maybe not. There might be something.
Maybe there's something else we need, but we'll figure it out. Okay, so the first thing we're gonna do is, well, do we want to address this specific one, or do we want to find it on the fly?
Let's find it on the fly.
Let's find it on the fly. Okay.
Oh yeah, you can also import light type.
Light type?
You can import light type, threading.
Well.
Yeah.
Oh, light type. Oh, so okay. Actually, that's interesting. I did look into light type. So, with this specific, I don't know if it's this model, but we only have one light type.
Okay.
There's like, I can't remember if it's passive light and direct light or something. There's some light bulbs with two different types of light.
Huh.
Or something. We only have one.
So there's a lot more expensive like models of Yeelights too. Like this is like the mid-range model, but they have like much fancier ones too. So it's probably other ones that like have like more hardware built in.
Okay. All right. So let's see what we get when we discover the bulbs. So discovery equals discover bulbs, and let's just print that and just see what we get for now. I mean,
why don't you just print the?
We could.
Oh, yeah.
We could.
Yeah, that's fine.
Okay. Let's see. All right. So
CD bulb, bulb pod.py.
Bulb.
Python bulb.
Py. All right. So I
Boop,
mean,
boop,
we've
boop,
already
boop.
seen what. Ooh,
Nothing.
you like that?
Yeah.
Oh,
Whole lot
that's
of nothing.
interesting.
Yeah.
Okay. So.
What network are you connected? Oh, you're connected to Ethernet.
That might be a problem.
I mean, it could be.
Okay.
So, well, let me see if I can address it, and then I'll try to turn it on.
I mean, I know the IP address, right? We could try it directly, but I mean,
Yeah,
if it's not finding it.
Yeah, try it directly.
All right. It was.
I just turned it on, so try running it again now that it's on. I mean, it shouldn't matter though.
No, it shouldn't.
No.
Yikes.
Yeah.
Okay, so we could try addressing it directly. Let's just see what happens. But I have a feeling it's not going to be very happy with this. I think it's 192.168.11.114. Is that it?
114.
144.
144.
Okay. Okay, close. And then if it worked, then we could do something like bulb dot. Is it on?
Yeah, just turn it off.
Turn off. Okay. So let's try that. Oh, it did turn off.
It turned. Oh, it did.
Yeah, interesting.
Okay, so it's not.
Okay,
So the scanning
what
module. What if you tried printing it? Rather than putting it in a discovery, just try printing it.
You mean discover bulbs?
Yeah.
All right.
I'm just curious.
Not used to this computer. Interesting.
Interesting. Yeah, it's just not really working on yours. I encountered this as well earlier, but I've managed to get it to resolve, but I don't remember exactly what the fix was. But
Maybe
for
I'm
now,
doing something wrong.
yeah. For now, anyway, like we already ran the scan and we know what the IP address of it is, so we can still proceed with actually doing stuff to it.
Okay.
Yeah.
Do you want me to write code like we're pretending like I didn't know it?
No. We worked on this in advance, so we can show you guys how to do some stuff. Yeah.
We definitely know this. Okay.
Yeah.
All right. So let's figure out what we want to do here.
Yeah.
We want to send messages in Morse code, right?
Yeah. So, okay, this is a sneaky way that if you wanted to communicate with someone in secret, maybe, we've talked about clandestine ways of being able to communicate with someone using like all sorts of weird dead drops and other stuff. But this truly is a very sneaky way where with like a long range Wi-Fi adapter, you could make someone's lights start blinking in their house to going according to Morse code. If that person knew Morse code, they would probably be pretty freaked out if there was a message coming from their light bulb. So like, you know, if you needed to communicate with someone, if you wanted to freak someone out, if you wanted to convince a child that there was a ghost, who knows? There's lots of reasons why you might want to sneak out data, for example. Maybe you were able to get a password. Yay. You know, if you were able to get information and sneak it out, or if you wanted to communicate to someone, this is all a creative way of being able to use this. But you can't do this just the way that I was doing it because there are timing issues. It basically will time you out after a certain point, and you'll have to stop, and it's very disruptive to being able to code this. So, yeah, there's a way around that.
Right. Okay. So I mean, earlier when we were playing around with it, we kind of saw that there was two ways of doing this. One is a very obvious Morse code, and then the other one was we kind of got to flicker slightly.
Yeah.
So it was a really subtle message transmission, which I kind of liked, but I don't know if it'll look as good on camera. So we're gonna.
I have to say, I prefer the second one because it looks really creepy. And if you were just in a hallway and like a bunch of lights were flickering, you're like, is that Morse code? And you're just like, each one had like a sad, scary message. You'd be like, I don't like this hallway at all. Why is it all flashing red? Like there's just so many ways of like pranking someone or like putting like creative messages into something like taking control of a bunch of smart lights.
Right. So you have to learn Morse code so you can intercept our messages.
Exactly. Yeah. If you see a smart light like flickering, just pay attention because if it's doing regular patterns, it just could be us.
That's right. Okay. So we have our bulb set up. We're gonna go ahead and enable the not magic mode but music mode.
Music mode.
Let's look at the API and let's make sure it's called music mode. So music mode. Yep.
Music mode.
Okay, so there's a function we can call, and it'll turn on music mode.
Okay.
And whoop, it's doing things. All right, so let's do it. So it can actually fail if music mode's already on. So we want to maybe catch that exception.
Right.
So it would be bulb dot music mode. All right, and I can't remember the exact exception. Except. So let's figure out what it is. Actually, whatever. We'll just catch it. Whatever.
Catch all. Yeah.
Yeah. We're not going to be too specific here. We'll just print something like music mode is already Ready on.
And for anybody that's not super familiar with code or Python, a try except prevents the code from just crashing anytime there's an error, like something not being there that we're expecting. So in this case, it just makes sure that we know what's happening if we encounter an error, rather than suspecting that another part of our code might be at fault.
Yeah, I like that. All right, and then if it was ready, if it wasn't on, then we could just print something like turned music mode on. Great. Okay, so music mode should be on. We will find out, if it crashes because it says, oh, there's too many connections, then music mode is not on. Great. So let's look at
By the way,
some
I'm
Morse
gonna move
code
this.
stuff.
I'm gonna move this light over here in between us, so it'll be
Okay.
super obvious when it turns on.
Oh, good. Okay. So let's look at Morse code. So I didn't know this before today because I think Morse code is a little too nerdy even for me.
Wow.
Which is saying something.
For a computer person. Wow.
So I don't know, is this big enough, you think?
It's fine. Yeah, that's good.
Okay. So, okay. So, I mean, do I need to explain Morse code?
Yeah. So if you are not a former Boy Scout or an old telegraph operator, you might not know Morse code. It's Brandon, I'm not going to explain Morse code. You do it.
Okay. I mean, letters become dots and dashes. So in the olden days, they'd have this little buzzer thing. If you're trying to transmit stuff over a wire and you only have, on or off buzzing noise, you want to translate your letters to these buzzing noises. So for example, a B is a long dash and then 3 dots, which usually means like,
Thank you for doing that.
Yeah. You want me to do it again? You want me to sing you out?
Please. Yeah.
Maybe after the show.
Okay. All right.
Okay. So let's say we wanted to write ABC. We can't just do dot dash dash dot dot dot. We have to make sure that there's the appropriate gap in between each dot and dash.
Right.
So let's say this gives it in terms of units. So if a dot takes 1 unit time, 1 second, let's say, then a dash is going to be 3 units.
Okay.
So we could turn on the light bulb for 1 second for a dot, and then 3 seconds for a dash. But that might be really long, so we'll probably cut it down. The other thing to know is that between letters, there's the same. There's 3 units of time, and then the space between words is 7 units of time.
Got it.
So
okay.
we'll try to make sure to include that when we're writing our secret message.
Cool. Okay, cool. So that basically just makes it easier for a human who is trying to follow along to be able to discern when it's like a word has ended.
Exactly. Right. Okay. Let's keep that up because I don't know Morse code. Oops.
Is there a Python library for Morse code?
Maybe. Probably. I mean, there's like a Python library for everything.
Yeah.
So let's just jump into it. All right. So now music mode on. Let's make sure we can turn on and off the light bulb with like a regular pulse. So why don't we just make 2 functions? We'll have one that's a dot function and one that's a dash function. So dot can be something like we want to turn it on for. We said a second, but let's define a unit time so that we don't have to change it when we change our minds. So let's just say unit time right now is going to be 1 second. And we'll do some delays with the time library.
Oh, look at this.
Actually,
sorry, I'll enlarge it a little bit. You can import Morse talk, and it will take any string. Let me switch over. Yeah, so as you mentioned, there's a Python library for everything.
Morse talk.
Yeah, Morse talk.
Okay.
In this case, if you import it, you can just have any string. Alpha Ranger 45 departed. I'm sorry, I watched the Power Rangers, but like not this version. So, but yeah, you can. But it looks like it's super simple. If you were to just define something and then link it to this result, you could take an entire string and do it this way. Kind of cool. All right.
That'd be cool.
Yeah.
Okay, so let's from time import sleep. So that way we can set delays and things. Okay. So for now, our unit time is going to be 1 second, but we'll probably shorten it down.
Okay.
So a dot for now, let's say the light is off, so we want to turn on the light. I think that's it. Turn on, and then we want to, we said we're going to turn on for 1 second, so let's sleep for our unit time, and then we can go ahead and turn off. Now, something else to note is actually I'll show it.
Mm.
Is that the light bulb takes a while to fully turn on
Mhm.
and takes a while to fully turn off. It's this like fading effect. So an option that the Yeelight library provides is that we're able to specify how long we want this transition to be.
Okay.
So we can either make this light bulb fade in and turn on for like a full second or 3 seconds to go from like dimmest to brightest.
Mhm.
But we don't really want that. We want
Right.
a pulse.
Right.
So let's look at the library. Let's look at the API and see what options we have. So turn on. Oh, actually, you know what? They give better examples in the home, I think. Let's see. Right, so here it is. So when you want to turn on, you can use an effect called
Effect equals sudden.
Right, and so that means, okay, well, let's just cut down the transition time and make the duration like nothing.
Could you show the difference between the two?
Yeah, let's do it.
Cool.
Okay, so let's get back to it. So let's comment this out and let's just show how long it takes to turn on usually. So let's just do bulb.turn on, and let's make the duration a full second. And I don't think the other keyword is necessary. So let's go ahead and run this.
Okay, so kind of gradual.
Yeah, I mean, and I don't know what the max is. Maybe we can make it 5 seconds. First, let's turn it off. Let's see. Great. So
Perfect.
Doesn't really seem like 5 seconds to me.
No, not
It kind
really.
of like starts. It kind of starts very, very dim. I don't know if the camera picks it up, and then it just kind of goes for it.
That's perfect.
Let's
All right,
see.
so as you can see, it's kind of going up and down in like a slow way. Can you trigger it again?
Let's do it again.
Yeah.
Okay.
So it's not flickering on immediately. It's actually for a period of time, taking a while to actually do it. So that means that it's really, really difficult for us to, like, for example, send a message because it's taking a lot of time by default to gracefully switch between different and kind of like doing like an animation sort of between different switches. So that's not what we want to do if we're trying to compress a message.
Yeah. Let's turn the animations off.
Yeah, let's do that.
Okay.
All right, so do you want to let me know when you're ready, and I'll hold it up so you can see the result.
Oh yeah. Okay. Sure. Are we back on my screen or?
Yeah, we're back on your screen.
All right. So we're gonna turn on for. We're gonna turn on. We're gonna. Oh, actually, well, I forgot to take off the animation, didn't I? What is it? Effect equals sudden, and that should cut off the time. I was playing around with it, and there might be it might be slightly shorter to actually use the smooth and then set a lower duration. But we'll play around.
Interesting. Okay, so some of the other arguments you can pass might actually produce a shorter result if you like play with the time settings.
Yeah. I wish I had more time to play with it and like see if I could really just like cut it off very harshly. But well, this will have to do for now.
Yeah.
So this will be a dot, and then let's make it do it a few times, I guess. Yeah. So we could. So this will be turn on, and then it'll hold it, and then turn off after unit time.
Okay, cool.
So let's just do a little while loop for a second here, and we'll do dot, and then we will just make it go to sleep for 5 seconds so we can tell the difference between a dot and just in between dot. Just for now. Okay.
Ready?
Yes. Let's do it.
All right, let's see the difference.
Oh, I did set a long sleep. Let's see.
Oh yeah, okay.
So it's shorter, but I think the effect. I mean, I think we got it even shorter earlier. Right?
Yeah.
Like
yeah,
that
I
doesn't.
agree.
Like it still seems kind of long.
Yeah, it does.
Okay, so let's work on cutting it down.
Yeah.
Oh, is it effect sudden? Yeah. Okay, yeah. So let's try effect smooth, And let's do duration equals 0. Right.
Cool. Yeah.
All right, here it goes. Ready? Oops. Ready? Oh, you know what?
What?
My unit time is still 1
1
second.
second?
Yeah. Okay, let's do that. Let's cut it down. How long are we gonna risk it? Maybe
Really short.
a third of a second.
Yeah, do it.
Because I think there is some kind of limit we have here. All right, let's see. And maybe I'll cut down the time it takes to cycle through.
Music mode is already on, you doof. Wow.
Yeah, I'm a doof. All right, let's see. So it's a little better. Should I cut it down more?
Yeah,
Let's
try it.
see what happens. We might get into glitch territory. Okay, so it's
shorter.
pulsing. Yeah.
Yeah, it's pulsing. All right, cool. Are you gonna risk it all? Yeah, do it.
I'm gonna risk it all. All right, let's see.
Dude. Oh,
that's pretty pulsing.
That's really good. Okay,
Yeah,
so
I
now
like
we're able to blink. This is really short, so we have pretty good control over the duration of the pulse, which I think is great. Okay, cool. Cool.
All right, so I think that's good for now. If that becomes glitchy, we'll boost it back up a little bit. But 0.1 is what it's at right now.
Yeah.
So
let's try to send a simple Morse code message then, because I think we're running short on time.
Okay.
But we've already managed to override some of the basic settings in here to basically do something that's not available by just default settings.
Right.
Yeah.
Okay. All right, let's just get a quick dash in there.
Yeah.
So according to Wikipedia, it's 3 times the unit time. So let's just do unit time times 3.
Nice.
Okay. And then let's send what do we want to send? SOS?
SOS.
Okay. So, and let's send that on a repeat. So,
All
true. SOS, right. So let's figure out what that is. I kind of already know, but let's just bring it up anyway. I think that's the only Morse code I know.
So it's 3 dots?
S is ... O is, where's O? Dash, and then back to S, ... So
Pretty easy.
to make it official international Morse code, between the letters, we're going to need 3 units of time.
Yeah.
Right? Between parts, the same letters, 1 unit. The space between letters is 3 units, and the space between words is 7 units. Okay.
Got it. All right.
All right, you got it because I'm going to ask you in a second, and you better remember.
No, I don't. I already forgot.
Okay,
All right.
so let's do it. So first we need a dot, then we need another dot. Oh, what we need also is time between the dots, right? Which is unit time.
Mm-hmm.
So we can sleep for unit time between everything we do. It's getting a little sloppy, but that's okay. All right, so, and we need another dot and some more sleep. Okay, so now we have to the dot, sleep, dot, sleep, dot, sleep?
Yeah.
Did I say the right number of dots?
There's 3.
Did I say 3?
Yeah.
All right, so then we're going to do 3 dashes.
All right.
So let's change these dots to dash, right?
Yep.
And then let's separate these out. And then this separates letters, so we actually need not unit time sleep. Do you remember how much unit time is between letters?
1.
1?
Sure.
I don't know. Okay,
Yeah.
well, let's check it out. This is going to be S, and then this is going to be the O, and then we're going to need another S. All right, well, let's just check. I just want to make sure. The space between parts of the same letter, the parts between letters is 3 units. All right, I don't know. All right, we're going to do it.
1.
You're right. Okay, O, and then we already have nicely the S, so we can just sleep for more unit time. 3 units of time. And then here's our other S, which is, there we go.
So if you need to, the culmination of this is if you need to indicate your distress to the world from a smart light that you don't have permission to address, then congratulations, you found the script you need.
All right, are we ready?
Yeah, let's do it.
Well, let's see if it works.
Whoa.
Is this
Wait. Hold on. Wait.
Is it smoking?
Wait, no. All right, try it again.
Oh, interesting.
I don't know that was a good thing. Hey, I mean, it's sort of... It's intimidating.
You know, it's interesting. We're getting this client code exceeded thing.
Aren't
Which is
we
interesting
doing
because
an
music. Right.
Are we? Let's maybe the unit time's too short.
Yeah. Let's increase it. Let's get back within safe range.
We were bold. We flew too close to the sun. All right, that's fine. Wait, that's fine.
I don't know.
Okay. Hey, that's
Okay,
pretty good.
that's pretty good. Now-
There you go. Congratulations. Look
Save
at this.
our souls.
Look at this. If we were holding this up from some sort of boat, then maybe someone would help
Great.
us.
Yeah.
All right, so this has been a really good way of just getting started with manipulating IoT devices that don't use authentication when it comes to controlling them. And today we were doing this from Python. We were just using a terminal to do all this. And for beginners or anybody who wants to get into IoT hacking, you don't need to be getting in there and changing the firmware and overriding everything in order to just start out doing this. You could go to, for example, maybe a coffee shop and find out that these devices are connected and willing to accept commands from basically anyone. So, of course, you shouldn't do that if you don't have permission, but I'm just saying it's possible. So, Brandon, what did you learn today about smart lights?
I learned that they need more unit time. I mean, you just can't cut it short, can you?
No. So one thing we did realize is that there are some limitations to this. Obviously, we're abusing protocols that are meant to be able to like make party lights go on, like during a party or something. And we're not able to do things that are like rapid flashing that might cause like an epileptic person to have a seizure. So like there are some limitations to all of this. So if your question was, can I cause epilepsy with this, or epileptic seizure with one of these, the answer is probably no. So there are limits to this. We haven't found a way to make them burst into flames yet. Brandon is working on that, and we'll get back to you. But for now, our production assistant, Michael, is very happy that we haven't found a way to destroy them other than just constantly factory resetting them.
Yeah, sounds good.
All right, so that's all the time we have today. Thank you again to Varonis for making this possible. If you want to check out some other great free resources, you can check out the Attack Labs. And you should also check out the Active Directory and PowerShell courses. They're a great resource for anyone who's interested in getting into scripting with PowerShell in Active Directory. Brandon, thank you so much for joining us today.
Thanks for having me.
Yeah, and this was a lot of fun. Catch Brandon on his sideshow, Brandon's Bits. And
Doesn't exist yet.
well, it doesn't exist yet, but we'll see. Yeah, and we'll see you guys next time. Bye.
Yeah.